So for this final part of the video on Busroot, I just wanted to go into a bit of detail about how we actually do the data capture on the shop floor. One thing we pride ourselves with Busroot is the ease in which we can automatically collect data from the shop floor and power all of these metrics that you're seeing. I know it all looks great on on a demo environment and on a screen. But how does it work in real life? How do we really get data into the platform? And I'll just talk about that quickly now about how we do it with a lot of our customers. So there is the tablet element, which I've touched on before when I was demoing the tablet piece. So we have these ruggedized tablet devices that we provide as part of our service. These provide essentially the interface to the operator. So these can provide work order instructions, the actual production orders to be worked on, the target quantities. The downtime detection comes through on these screens. So when we detect that downtime, it comes up in red on the screen, as I showed earlier. They can then input kind of downtime reasons code. So it acts as an instruction piece to the operator. It also acts as a data capture piece for us as well. So we're capturing production counts, and we're capturing those downtime reason codes. So for human-led operations, this tablet is the primary way in which we collect information. For automated machines or for machines which we're capturing data from automatically, a lot of the times we will still use a tablet on the outside of that station because it still provides useful information to the operator about what they're working on and their progress through that. But it also allows us to capture those downtime codes, even where we are automatically capturing data from the machines. The way we automatically capture data from machines is essentially through a mini PLC device. We do not manufacture this hardware. It's essentially open source based hardware. It's worth noting that Busroot can work with any range of hardware. We just have a set of APIs that ingest these data points. What we have used here is an off-the-shelf mini PLC. It's Wi-Fi enabled, so we wirelessly connect that data. We have written software that goes into this device, and it uses the inputs along the top here to collect those production count signals, the utilization signals, the line speed signals, and doing a lot of that automatic data capture for us. That can come directly from digital PLCs, so we can talk to, this is a mini PLC, but it's not really used as a PLC. It's used as what we call a data acquisition unit. But we can talk to other PLCs in the machines to be able to pull tags, so line speed tags or whatever they may be automatically. If that's not an option, either because there is no PLC or the data isn't available in that PLC, or we just simply don't want to interface with the PLC, it can also be used directly with sensors that are on the equipment already. So a typical example of what we might do with a customer is an and-on light. I've mentioned that before. So the and-on light can be kind of linked to this device so that we can also read what that's doing. From the and-on light, we get asset utilization and we can get production cycles. We also have connected into things like packaging machines go through a cycle for each packaging that they do. For example, inside that machine there might be something that cuts the packaging or finalizes that, and we can tap into that signal and count that. So there's a lot of different options we can use to kind of pull some of the information that we need into this box. It's really a universal box for us. We don't program this box specifically for any customer. The box always gets shipped with generic kind of firmware on it that we've written. What happens is you then connect this device to the Wi-Fi, so you input your Wi-Fi details into this. The input pins at the top are generic. They can be used for any purpose. That doesn't need to be pre-configured. Those pins get used, and then in the cloud, in Busroot, we then configure what each of those signals mean, so that during the installation process, we'll get told that input 1 is the and-on light for machine 1, input 2 is the production count for machine 1, input 3 can then be used for maybe a second machine, and so on, all done in the cloud and configured remotely. So it makes the installation process very, very simple for us by using a device like this. And this device also connects through to energy monitoring. So it really is a universal device for us. So using the Modbus protocol here, we have a 3-phase power monitor. This is giving very granular information on obviously energy usage, but it's also giving us very granular information on each of the phases. So voltage, amps, power factor, things like that is all being captured by this device at a very high frequency. We're passing this over to, again, our data collection unit, data acquisition unit. This data acquisition unit is then wirelessly transmitting that information back to Busroot. So it's really serving a lot of, it's doing double duty. It's doing more than that in terms of capturing all of these different signals, potentially from multiple different machines, and talking to energy monitors. Because we're using the Modbus protocol, these energy monitors can actually be daisy chained to a single device. So a single unit like this, we could daisy chain up to 16 energy meters as well. So we have quite a few customers that are using these from multiple machines from a single device, all again being wirelessly transmitted back to us. So between this device, the energy monitor, and the tablet device, that's our kind of standardized way of doing that automatic data capture from the shop floor. It's working very well so far. We're finding a lot of the internal maintenance teams are really happy to kind of install these themselves once we've given them this documentation as to how this works. And there's really not much to it. You supply it with 12 volts power, 24 volts power, which is fairly typical inside the cabinet. Like I said, these are isolated pins into electrically, so they have no effect on the actual operation of the machine. You just wire those signals in, and like I said, through the cloud management software, we then map these signals to what they actually mean inside the platform. Okay, hopefully that's given a bit more insight into the nuts and bolts of how we work on the shop floor. As I said, going forward, we're not. This is not by no means the only hardware that Busroot would work with. It's simply a set of APIs that we're interacting with to be able to provide that information into the system. So if there are other methods, directly getting that information from the PLC or from other information systems, we work with some customers like that as well, where they actually already have machine monitoring software that's maybe come from the vendor of the equipment itself, and they don't need this at all because the machine is already connected. It's already providing a lot of this data. They just don't have a way of bringing it into a single platform and comparing it to their production schedule and all of that stuff that Busroot does. And no hardware is required. And actually, we just have an import script or an integration script which pulls that information from the third-party software and just pulls that into Busroot to give them a complete picture of their shop floor. So it's really flexible. There's lots of different ways we can work with this, but hopefully that gives a bit more information on the hardware front.